It's an odd-looking device, but it could be the forerunner of farming in the future. Researchers at the University of Illinois in Urbana-Champaign are developing robotic weeders, computerized, self-contained machines that run on batteries or solar power.
These are actually infrared sensors, and those infrared sensors, we use them for guidance of the robot. There's two kinds here, there's long range and short range, and that allows us to measure the distance between the sensors and the corn stalks.
Dr. Tony Grift is one of those leading the research on farm automation. On this robot, an onboard camera identifies specific weeds and goes on the offensive.
This is actually a weed detector. So as you look down here, this is a system where we have 4 laser beams. You can't see them right now because it's way too bright. But the 4 laser beams are being interrupted by the corn plants. Now there will be weeds in between. But this system with 4 laser beams is smart enough to figure out exactly where the corn stalks are and also to distinguish them from the weeds.
Once identified, the robot would then eradicate the weeds, getting rid of them mechanically or by a select application of the correct herbicide. Students and professors here have come up with a number of different designs. And while weeding addresses an immediate interest, Dr. Grift sees this as just the first step.
Full-scale agriculture automation, where you have multiple vehicles running through the field, they're all networked, they all talk to each other, and they pretty much run the farm by themselves.
Nathaniel Gingrich is a University of Illinois graduate student whose work in automation is part of the project. His robotic weeder utilizes not 1, but 2 cameras.
And the stereo cameras are hopefully be used for navigation. They'll be able to identify the rows and to navigate between the rows, and then also to look for the weeds and actually identify where the weed is. And because it's a stereo vision, it actually can tell the depth of where the weed is in its position to navigate the arm into position.
That arm then swings into action with sharp blades that move on the target.
We're looking for the robot to go and search out and find a specific weed, a single weed, and then actually go down with the blade and cut the weed mechanically, and then also at the same time apply herbicide directly to the weed.
For now, cost is a significant issue in robotic field work. Prototypes can cost thousands of dollars to construct. But researchers here and elsewhere are examining a variety of designs from large to small. And if cutting a single weed seems like a slow process, remember that robots can work in teams 24 hours a day.
Building machinery that is intelligent enough to find the weeds themselves and also do the operation at the time you want to do it. For example, if these robots look at their own internet connection and they find out from a weather map that today might not be the best day to do it, then they can go and say, let's schedule something else to do today and then do the weeding tomorrow.
Weeds are only part of the story when it comes to this futuristic look at automation. Now, GPS systems have long been used in operating many pieces of farm equipment, but automation engineers want to expand that technology to improve onboard computerized capabilities. The tractor working this research plot in Champaign County, Illinois, has no driver. It can be operated by remote control and by onboard computer. Researchers here think that automation can help farmers work better by relieving them of tedious, repetitive tasks.
When you use a long baseline camera, then we can maybe see further away.
Yes. Dr. Quinn Zhang says that adding a camera to the tractor grill and connecting it to an onboard computer advances the potential even further.
This technology basically is just try to mimic a human eye. So it just looks like we put a pair of human eye on the tractor.
Dr. Zhang says a driver would still sit in the cab to ensure safe operation, but says the computerized autonomous tractor would eliminate long hours of hands-on driving. The eyes would also relieve the need to watch for obstructions that might cause an accident.
He or she can still enjoy the field work, but the tractor, the computer, the vision system can take over the routine navigation. It can always alert. So if when see something unsafe, it can immediately give alarm or automatically shut the machine down to avoid any accident from happening.
These ongoing onboard diagnostics can also monitor specific critical engine parts. Knowing when a part is just about to fail allows the operator to avoid making costly repairs too early or too late when a breakdown could affect field work.
And to analyze those signals to tell if the component is still running in the normal condition or it's close to end of its expected life. Repair the machine before season start. So we can prepare the machine, make sure the machine will never broken down during the season.
It may not be Star Wars nor R2-D2 ready to attack the weeds, but engineers here believe this new realm of technology will translate to real-world applications in the very near future.